The next 3 slides summarize what we have discussed so far in demonstrating the use of array for storing and manipulating a set of scores. This is a screenshot of the Bourget environment that declares a reference variable for the array score array, and the declaration of a constructor and the method setScore for entering the scores into the array. The 2 methods here, getScore and fScore, will allow scores to be retrieved from the array and to compute the average of all values in an array. The maxIndex method returns the location of the largest element in an array. Notice that this method finds the location of the largest element rather than the value of the largest element. We discussed in details how to swap 2 elements in an array properly and the mechanism of passing the reference variable of an array into another method. Let's now try to put all these together and develop an important operation that is often used in manipulating arrays. The operation I'm going to discuss is sorting. Sorting is the process of arranging a list of items in certain order, for example, in descending or ascending order, using numerical or lexicographical order. Many applications require sorting. For example, to order a group of students according to their names, ID, and examination scores, to arrange a list of events in chronological order, to facilitate the search for information. For example, in dictionaries, imagine the difficulty of finding the meaning of a word from a dictionary if the words are not in alphabetical order, although not many of you use dictionary anymore. And to look up a telephone number from a contact list is a lot easier if they are ordered. To display a list of web pages based on their popularity, for example, using the number of hits, you are seeing such ordering every day when you do a Google search. Sorting is one of the most studied areas in computer science. There are many sorting algorithms available. What I'll do here is just to give you some idea on how sorting could be done, and an algorithm that is easy to understand rather than introducing the most efficient or sophisticated sorting algorithm. The sorting algorithm that I'm going to introduce is called selection sort. The idea of selection sort is quite simple, and it follows the way many of us would perform sorting. Assuming that we are sorting the items in ascending order, that is, from small to large, selection sort would divide an array to be sorted into 2 parts, a sorted part and an unsorted part. Initially, the entire array is considered unsorted. You will then perform sorting by repeatedly finding the largest element in the unsorted portion of the array, and then place it to the end of the unsorted portion of the array until the whole array is sorted. To describe the algorithm in arithmetic form, the first step is to set up the entire array as unsorted. The next step is an iterative process that would first find the largest element in the unsorted array, and then swap the largest element with the last element in the unsorted portion of the array. After the swapping, the unsorted portion of the array is reduced by 1. To help you understand how this works, we have created a Java applet that could generate animations to illustrate how the selection sort works. You'll find this Java applet in the course website if you want to play with it.
Search through the array, find the largest element, 10, and swap it with the last element, 5, in the unprocessed portion of the array since they are different. Note that the whole array is unprocessed at the beginning, which is in yellow. Now, find the largest element, 9, in the unprocessed portion of the array, and exchange it with the last element, 1, in the same portion of the array since they are different. Note that this is identical to the above step, except that we don't search the last element. We already know that it is the largest. Also, note that the processed portion is now in blue. They will not be changed anymore. Now, repeat the find and swap process in the unprocessed portion of the array. After each process, one more element becomes blue. That is, one more element is being sorted. the whole array is sorted.
Let's now try to implement the selection sort into a Java program. You may think that it could be a quite complicated program. Surprisingly, this is the entire implementation of the selection sort. We begin by declaring a variable maxPos, which is used for keeping track of the largest element in the unsorted portion of the array. We are making use of the methods maxIndex and swap that we developed earlier. This is why in the implementation of the maxIndex method, instead of returning the maximum value, we want a method that could return the location of the maximum value so that we could do the swapping using the position or the index. The setting up of the for loop is to repeat the finding of the largest element and the swapping steps. Notice that I in the for loop starts with scoreArray.length -1 because that is the last index of the entire array, which is considered unsorted at the beginning. And the I ---- here is to reduce the size of the unsorted portion of the array by 1. Notice also that the argument used when maxIndex is called is I + 1 because if you go back to take a look at the method maxIndex, its parameter is supposed to be the size of the array from which the method is finding the largest element, and the size is 1 larger than the maxIndex. And for the swap method, we are passing the address of the array to the method, and the second and the third parameters are the indexes of the array elements for the swapping to take place. You may want to track through the select sort method to make sure that you understand how it works. This example would hopefully help you to see the beauty of using modular design and procedural abstraction, which allow a complicated process to be implemented in just 3 statements.